Hello everyone, welcome to the free CCNA classes again. I'm hoping that I'm clearly audible to all of you. Awesome, great. I'll just share my screen in a minute and then we are good to get started. All right, my screen must be visible now. And in the previous session, we spoke about EIGRP protocol. We tried understanding the basics of it, the fundamentals, and then looked at some configuration in which we also observed how the cost calculation is being done. And then we tried out understanding how the dual algorithm works in EIGRP. The topic we have got for today is called OSPF, a very important protocol from the CCNA syllabus. We'll try to understand how OSPF works today. We'll try understanding all the characteristics and features related to OSPF, and we'll be observing some basic labs as well. So let's see how we can achieve this. OSPF stands for Open Shortest Path First. Open Shortest Path First, or OSPF, is another dynamic protocol that we use for connecting different networks together. So far, we have discussed about RIP EIGRP. When we spoke about RIP, we said it is distance vector protocol. When we spoke about EIGRP, we called it advanced distance vector protocol. Now we are talking about OSPF. For OSPF, we use the term link state routing protocol. We can say it is also known as link state routing protocol. Now we call it link state routing protocol because OSPF router contains information of complete topology and takes the best route decisions or finds the best path on the basis of link speeds, the bandwidth. Bandwidth of the link is the factor which decides if a path would be selected as the best route or not. Then OSPF is Open Standard Protocol. We have discussed earlier also that open standard protocol means a protocol that can be used with all the vendors. Then the algorithm used by OSPF is SPF, which stands for shortest path first, or Dijkstra's algorithm. Dijkstra was the person who created this algorithm. So we say that OSPF works with shortest path first or Dijkstra's algorithm. Akshay, try to rejoin the session if you can't see my screen. In the case of RIP and EIGRP, there was a limit on the number of hops. Can you let me know what was the number of hop limit with routing information protocol? 15. What was it for EIGRP? For EIGRP, it was 255. Now in OSPF, there is no such limits. You can connect as many hops as you want. So unlimited number of hops can be connected. Then the metric used by OSPF is cost, and cost can be calculated with a formula which is reference bandwidth divided by the link bandwidth. Reference bandwidth, which we consider in OSPF, is 100 Mbps. So 100 Mbps divided by the link bandwidth would give me the cost of a particular route. Any questions so far? Okay. Let's try to calculate the cost for an Ethernet link. What is the bandwidth for Ethernet links? Is 10, right? Puja, bandwidth plus delay was something that we use with EIGRP. Now we are talking about OSPF, so things are different here. So for Ethernet, the bandwidth is 10 Mbps. And if I calculate cost for an Ethernet link, then the OSPF cost is going to be 100 divided by 10, which is going to give me 10. So the cost for Ethernet link is going to be 10. Similarly, cost for fast Ethernet, for which the bandwidth is 100 Mbps, will be 100 divided by 100, 1. The cost for gig Ethernet, which offers 1000 Mbps of bandwidth, will be 100 divided by 1000, 0.1. So we round it off to the nearest integer, which is 1. Okay. Now the problem is that my OSPF will consider a fast Ethernet route as well as a gig Ethernet route as equal. Like if R1 is connected to R2 and R3 and is also connected to R4. Let's say the bandwidth here is 100 Mbps and the bandwidth here is 1 Gbps. Which route according to you is better? Second one, right? But in this case, if we calculate the cost for 100 Mbps link is going to be 100 divided by 100, 1. And for 1 Gbps, the cost will be 100 divided by 1000, 0.1. And like I said, we round it off to the nearest positive value. So we'll make it 1. Correct? So when the cost is 1 via this link and 1 via this link, that's bring me to equal cost load balancing. That brings us to the situation of equal cost load balancing, like we discussed in the case of EIGRP also. So in this scenario, the packet will be transmitted on both the available links. Why? Because reference bandwidth is not able to make a differentiation between a fast Ethernet link and gig Ethernet link. But let's assume for some time that OSPF had the reference bandwidth of 1000. In that case, reference bandwidth would have been like this, and the calculation of this division would give me 10, whereas the calculation of this division would give me 1. Now, can I differentiate between the links? If the cost for this one is 10 and cost for this one is 1, OSPF will be able to understand that this is a better path, right? So whenever you are using links which are, let's say, greater than fast Ethernet link, for example, gig Ethernet or even 10 gig Ethernet, then we can increase this reference bandwidth. We can change this reference bandwidth to something higher or to something greater. And we'll have to do this on all the routers so that we, take the same decisions everywhere. So in a situation where we have links which are from the which offer the bandwidth greater than 100 Mbps, we can increase our reference bandwidth from 100 Mbps to something else. But like I said, we have to be very cautious and we have to keep it same on all the devices. Otherwise, there will be suboptimal routing decisions. I hope that makes sense to all of us. Yes, Saurabh, a route having lesser cost would be considered as better path. Sure, I can repeat this for you guys. The scenario was this: R1 was connected to R2 and R3, and both are taking us to R4. The route via R1 is having bandwidth of 100 Mbps. The route via R3 is having bandwidth of 1 Gbps. So we can say very clearly that this is a better route, right? But OSPF will consider both the routes as same because the calculation brings the cost as same for 100 Mbps links as well as for 1 Gbps links. So to make that differentiation, we increase our reference bandwidth. From 100 Mbps, which is the default reference bandwidth, we can increase it to, let's say, 1000 Mbps. Now, once it is 1000 Mbps, for my fast Ethernet link, the cost will be 1000 divided by 100, which will give me 10. And for gig Ethernet link, my cost will be 1000 divided by 1000, which will give me the cost as 1. Now, when the cost for this path is 10 and this one is 1, I'll be able to differentiate between them and make the decision that this is the better path. I should forward traffic via R3. Make sense, guys? So that's why, or in these kind of situations, we change the reference bandwidth from 100 Mbps to something higher. I'll show you the command. Don't worry about the command, but just understand the concept as of now. Yes, Sayyid, that's correct. Yes, Ashish. If the cost of a path is less, that means that's a better path. Then, Nicholas, if you have different types of links, then the calculation will be done accordingly. For the fast Ethernet, you will consider the cost as 10, and for gig Ethernet, you will consider the cost as 1. I mean, if you have changed the reference bandwidth. Reference bandwidth, like I told you guys, by default will remain 100, but we can increase it in case the differentiation is not something which is happening. So in case you want to work with higher bandwidth links, which are like gig Ethernet, fast Ethernet, 10 gig Ethernet, you can also increase your reference bandwidth. All right. Then the AD value of OSPF routes is 110. Then OSPF routes are also updated, or we can say OSPF also uses triggered updates. So when a new information is added, that information is triggered to the connected neighbors. So it uses triggered updates on 224.0.0.5. That's the multicast address for OSPF, and 224.0.0.6. So there are two multicast addresses. One is used by the normal routers and the other is used by the designated router. What is designated router? We will figure out later on. Then the hello time in OSPF is of 10 seconds. So every 10 seconds, my neighbors and I will share an hello message. And if I don't get a reply for my hello messages for 40 seconds, I will consider my neighbor as down. And we call this timer as dead time. So dead time is 40 seconds. Then OSPF is a classless routing protocol. Also, OSPF works on the concepts of areas. Now, what is area? Area is a virtual group that we create for multiple routers for limiting the number of packets which are generated by the devices inside it. I'll speak more about it later in the session. As of now, just understand we'll create multiple areas, and inside that my OSPF neighborships will be established. Other than that, there are few neighborship parameters which we have to match on both the devices before we can assume two routers to become OSPF neighbors. So what are these parameters? Let's understand. Just a minute, guys. So OSPF neighborship criteria are there. Which includes three things. First, you need to make sure that your routers are participating in same area. So the area number that you create, both the routers should be part of it. Then they should be on same subnet. Their network should be same. And their timers should also be same. The hello and dead time that we have mentioned, it should match on both the devices. Otherwise, OSPF neighborship will not get established. Clear? Then we discussed there are some tables which are maintained in EIGRP. So let's also understand what all tables are maintained in OSPF. First is neighbor table. Which can be checked by using the command show IP OSPF neighbors. Second is database table, which can be checked using the command show IP OSPF database. Third is routing table, which we can check using the command simply show IP route. Clear, guys? Perfect. Now, before we get on to the lab part, I want you guys to understand why do we require OSPF areas. Okay. So when we connect, let's say multiple routers together, they also exchange some messages, right? To maintain the neighborship, to share the routing information, to share the network information with each other. Now, when any new network is added into the domain, that update is also provided to everyone, correct? So when we have, let's say, 1,000 routers and there is a new network added on router number 1, then R1 will flood out updates to all of the 1,000 connected neighbors. Now this can lead to a packet flooding, right? This can lead to a flood of updates between all these 1,000 routers. Everyone will start updating each other that there is a new network added into the domain. And this so many packets can also lead to overutilization of CPU and RAM, making my router down. This can lead even to crash the router. So what we do is we divide them into different areas. We'll put them into an area. After I put it into an area, the updates or the information or the packets will get a little limited within this area. Make sense? So whenever a change will happen, the updates will only stay inside this area. Other areas which are connected to it, let's say another area which is here. Okay. Let's say this is another area which is connected to my first area. This area will also be updated about the change, but with a limited number of packets. So I will not basically get into a situation where I have so much of packet updates or so many messages which is being exchanged between the devices. Because what I did, I divided my 1,000 number of routers into, let's say, 20 different areas. So now they are bunch of routers in 20 areas which are going to exchange updates with each other. Do we understand why we require area in OSPF configurations? Okay. Now there are two types of areas. One is your backbone area, which will always be area number 0. And then you have your normal areas starting from 1 and going up to somewhere around 4.3 billions. Now, what is so special about area 0 that we call it backbone area? Let's understand. Let's say you have area 10 here. This is your area 10 and this is your area 20. Okay. Now, if you wish to connect area 10 with area 20, you cannot put a direct cable and connect those routers. That's not possible. You will have to include a backbone area into the situation, which will be your area 0 always. And area 10 will be connected to area 0, area 20 will be connected to area 0. Then only my area 10 packets can communicate to area 20 devices. Clear? So the packet or the traffic needs to flow through the area 0 if it wants to make a communication with another area. That's why we call area 0 as backbone area. It's required for connecting two different areas together. Any questions? No, Michael, area 0 is not internet. For internet, we use a different protocol. We use BGP for that, right? Right now, we are talking about OSPF. All of this will be created within my organization. Right now, I'm understanding how I can connect internal gateway protocols, the network which is internal, not the external. Yes, Sayed, by like a direct connection can never be created between two normal areas. It has to pass through the area 0 only. Now we have a question, great question, which is also our lab for today. What happens if we just have two routers involved in the network? If I have a very simple and small topology, which is of just two routers, R1 connected to R2. So I can put them in a single area and they both will communicate to each other. Let's say area 10. Okay. I can put area router 1 and router 2 both in the area 10 and they'll be able to speak to each other. Yes, like someone has mentioned here, it can be any area, not specifically 10, but anything 10, 11, 12, anything from the range. Another great question, how many routers can we add in one area? There is no such limit to adding the number of routers in your area, but there are always suggestions to keep it either in the range of 0 to 50, or if let's say you have too many devices, then the maximum you can go for an area is 100. But yeah, like I said, there is no such rule which defines how many basically routers can be added in one area. It's totally up to how busy the network is. If let's say my two routers only, or let's say my 50 routers only, uh, exchange too many packets. There is so many updates, so many networks working between those 50 routers. So it would be a good idea to even divide those 50 routers in multiple areas so that I can manage things easily and in a better possible manner, right? If area 0 is down, your connectivity will be lost. Why is it only area 0? That's how the OSPF is designed. We can't help. I mean, we don't decide who will become backbone area. It is always area 0, nothing else. That's a rule of OSPF, we can say. Yes, Sayed will be looking to that. I mean, after we are done with the theory discussion, we'll do the lab. Okay, let's do this lab where we'll connect R1 and R2 together and we will try to put them into area 10. So Their area is going to be same. Their subnet will also be same, 12.10.1.0/24, let's say. And by default, the timers are also going to be same, where the hello time is going to be 10 seconds and dead time is going to be 40 seconds. So that's going to be same on both the devices, which means I am meeting all of my neighborship criterias. So if we are meeting all the neighborship criterias, the OSPF neighborship should come up. So let's try this configuration and see if we can connect two routers together using OSPF or not. I'll open my packet tracer and we'll create this quick lab. My screen must be visible now. I'll take two routers, 2811 series, router 0, router 1, and I'll connect two switches with them, and then some end devices, PC0, PC1, PC2, PC3. First of all, we will do the cabling. And like we have discussed, I will put both of my routers into area 10. And the network that we'll use between the routers is going to be 12.10.1.0/24. The network for my LAN 1 is going to be 192.168.1.0/24. And the network for LAN 2 will be 192.168.2.0/24. Let's begin the configuration. First of all, I'll go to my router 1 CLI and I will put basic IP configs. Say no to the question. Enable config T host name R1. On the interface FA0/0, I'll put the IP address as 192.168.1.1/24. No shutdown, exit. On the interface FA0/1, IP address will be 12.10.1.1/24. No shutdown, exit. Then I'll create a DHCP pool for my network 192.168.1.0 with a default router address as 192.168.1.1. Similarly, I'll go to my router number 2 CLI and will put the IP configurations. Enable config T. Config T host name R2. Interface FA0/0 IP address 12.10.1.2/24. No shutdown, exit. Then interface FA0/1 IP address 192.168.2.1/24. No shutdown, exit. Once that is done, I'll also configure DHCP pool for my network 2, which is 192.168.2.0.255.255.255.0. Default router address will be 2.1. Clear? IPs are assigned, DHCPs are configured. Let's provide IP to the end devices also. I'll go to PC0 desktop IP DHCP. Done. Then I'll go to PC1, desktop IP, DHCP. Similarly, PC2, desktop IP, DHCP, desktop IP, DHCP. Now, for obvious reasons, if I go and try to ping 192.168.2.2, that's going to get failed, right? Because my router 1 doesn't have a route for reaching this network. And we can see it tells me destination host is unreachable, right? So let's make R1 and R2 configured with OSPF so that they can know about each other's connected networks. I'll go to my router number 1 again, and we will configure OSPF. Router OSPF question mark. This is called process ID. In the previous configuration, when we were implementing EIGRP, this number used to represent autonomous system number, right? In the case of OSPF, this number is process ID. It's not autonomous system number. Autonomous system number was something that had to be same on both the routers to bring up EIGRP neighborship. But in the case of OSPF, that's not the case. The process ID can be different on two routers and they can still become neighbors. Make sense? So process ID is basically just a local representation of the OSPF process. It can be different or it can be same. Doesn't matter. The neighborship will come up if the network is same, the area is same, and the timers are same. So router OSPF, I will take the process ID as 100. Enter. Then I will add my connected networks. Network 192.168.1.0. Then I need to add the wildcard mask 0.0.0.255. Then I need to specify in which area are they participating. So they are participating in area 10, right? Similarly, network 12.10.1.0 wildcard mask 0.0.0.255 area 10 and exit. That's how simple OSPF configs are. That's all. Similarly, I'll go to the router number 2 and I will configure OSPF here also. Router OSPF 100. Now I am keeping the process ID same just for the identification. But like I said, it is not mandatory. You can have different OSPF process ID on both the different routers. But usually we keep it same because we are considering the same process, right? So OSPF 100, then I'll say network 192.168.2.0, 0.0.0.255 with the area as 10. Similarly, network 12.10.1.0, 0.0.0.255 area 10 and exit. Let's see if the OSPF neighborship comes up. There you go. OSPF neighborship is up. Under the process 100, we have identified a neighbor 192.168.1.1, which is my router 1. Then if I go back to PC0 and again try to ping 2.2, let's see what do we get. You can see we are getting the replies. That means the connectivity is successfully established. That also means that now R1 should have got the route for 192.168.2.0. How do I check my routing table, guys? What's the command for that? Show IP route is the command. Here we can see the OSPF route for 192.168.2.0/24. What is the AD value? 110. What is the cost value? 2. Reachable via 12.10.1.2. And then this is the uptime. This is the exit interface. Let me know what questions or doubts do we have from this. Meanwhile, I'm sharing a lab guide for you all to practice the same. Yes, Sanju, if router area, area zero's router goes down, then yeah, connectivity will be lost. Solution is keeping redundancy. So redundancy will allow you to have multiple options of reaching destination. We have a question here, how the cost is 2. So guys, there are two networks. And from R1, if I want to reach 192.168.2.0, first of all, the cost for this link would be 1. Then from router 2, we are taking exit. That's again a fast Ethernet link, right? Again, the cost will be 1. So 1 plus 1, 2. Michael, the AD values are predefined for the routers. For the routing protocols. We can't help with that. But yeah, if we consider for internal communication, a router will prefer EIGRP information over OSPF. I've shared the lab guide. Please try the same and let me know once you are done. I'll give you around 15 minutes to experiment with this. All right, I'll quickly show you the command to change reference bandwidth. Although, like I said earlier, this is not usually what we do. It's a complicated configuration and should only be done if you are sure about how it's going to create an impact on your network. I'll just show you the command right now. You get into OSPF, router OSPF 100, and you say auto cost reference bandwidth, and you can set the bandwidth between whatever, you can set it as whatever value you want between this range. Like by default, it will be 100, but if you want to use 1000, so you need to type 1000 and hit the enter button. I am putting a screenshot of this one, but yeah, I do not recommend this until and unless you are sure what impact it is going to create on your network. Okay. All right, we have a good number of questions here in the chat, and I'm excited to teach you guys about this another way also. And I wanted you guys to explore it by yourself. So, guys, that's also one way of putting OSPF configurations. And as you might have observed in your uh, lab guide, in that case, you are not advertising networks. You are just putting the interfaces directly into that area. Okay. And the range command is used for selecting multiple interfaces together. Like in the lab guide, you can see it is given range 0/0 to 1. That means you are selecting 0/0 as well as 1. So please continue to follow it, try it, and then we will discuss more about it. Router ID is something we are yet to discuss. Don't worry about it. Just please practice the lab that we have discussed. Whatever way you like. If you like this way that we have tried here in the demonstration, you can follow this way using these commands. If you like the way which is mentioned in the lab guide, you can follow that one. All right, guys, I hope everyone must have completed this by now. Many of you have used the way that I showed here in the session, and many of you have used the way which is mentioned in the lab guide. The lab guide way is no different. It's exactly the same thing. And it's just that you are adding interfaces directly instead of telling the networks to the router to find out the interface by itself. Sure, we can take 5 more minutes if you all are working on it. So let's take 5 more minutes and then try again. I mean, then we will continue. Guys, it is not necessary to take area 0, area 10. That's totally up to you. I used an example with area 10. The lab guide was with area 0. So that's not different. I mean, it's totally your choice. Okay. It doesn't create a difference. Until and unless you don't have multiple areas in your lab, you don't actually need area 0 specifically. Okay. But yeah, if you have multiple areas, if you have area 10, 20, 30, and you want to make them communicate, then area 0 is required. No, to connect two different areas, you always need area 0, not just a random area. But to connect two different routers together, it can be any area. Yes, a router can be a part of more than one area. We will look at that scenario also in our next example about multi-area. You missed on configuring no shutdown command, Shreya. That's why it is down. Or otherwise, if you have configured it, then on the other side, the router must be down. So that's the reason why you would see the interface to be down or the protocol to be down. Yes, Ankush, you can configure more than one protocol. Shreya, I'll have to check the topology and the configurations you have made to figure out what exactly is the problem with the interface. Shall we move ahead, guys? Let me know if we all are done with the lab. Whenever I add a new interface router, it happens like that. It shows protocol is down for the newly added interface. Shreya, then it could be some bug also from packet tracer. Are you able to ping the devices correctly and everything is working fine? That should not be the problem, Shreya. You must be missing on something. Like for example, I'll show you, I'll take one switch here and I'll connect some end device also. Now to connect this cable from switch to router, I'll have to add new interface on it, right? So I'll go to my router. I'll save my configuration. What is the command to save configurations, guys? Once the configuration is saved, I will shut down my router. I will add interface. I'll start it and I'll connect my cable like this. Now, if I go to my router CLI, enable, sorry, enable show IP interface brief. We can see, first of all, for FA1/0, right now there is no IP configuration and my interface is also automatically up. Okay, that's the first thing. But in case, let's say it is down, and if you have used it for connecting to LAN, you can put IP on it by selecting the interface FA1/0, set an IP on it, let's say 210.1.1/24, and then simply say no shutdown, exit. You can see my interface is perfectly up. For FA1/1, it is down because so far I haven't configured any IP or connected any device with it, right? Once I connect a device, once I configure an IP and write down no shutdown, this interface would also come up. Go to the interface and try running no shutdown again. Otherwise, try creating a new file. Probably you are missing on something, and that's causing the issue. Okay, I'll show you one more example. You don't have to do it, but I am just showing you for making you all understand about the way which basically we have used in the lab guide. Okay, so this time we'll take 3 routers and I'll connect 2 switches like this and some end devices. And I'll connect my cable like this. In this case, I will configure all the 3 routers into area 0. The network for this is going to be 210.1.0/24. For this one, it will be 210.2.0/24. Between R2 and R3, I'll take 2310.1.0/24. And here I'll take 3410.1.0/24. This will be my area 0. Let's first of all configure IP addresses. Go to my first router CLI, say no to the question. Enable config T host name R1. On FA0/0, I'll configure the IP address as 210.1.1/22. No shutdown, exit. Then on interface FA0/1, I will configure IP address as 2310.1.1/24. No shutdown, exit. Now I'll go to the next router, FA00, FA01. Both we will configure with IP. Config T, we'll call it R2. FA0/0 will have the IP 2310.1.2/24. No shutdown, exit. On FA0/1, the IP is going to be 3410.1.2/24. No shutdown, exit. Then I'll go to the final router, router 3. Say no to the question. Enable config T host name R3. FA00 IP address 3410.1.3/24. No shutdown, exit. Then interface FA01 IP address 210.2.1/24. No shutdown, exit. As of now, simply we have added IP configuration on all the devices. Now let's create a DHCP pool for this network and this network, right? I'll go to my first router. I'll create a DHCP pool, IP DHCP pool A for 210.1.0 with a gateway address of 210.1.1. Similarly, on the router 3 also, I'll create a DHCP pool for my network 210.2.0/24. Sorry, default router address 210.2.1. I'll go to my PCs. I will configure IP address on them. And we are done. Now it's time to configure OSPF. So I can say that router 2's interface FA00 and FA01 both will be participating in area 0, correct? So I can configure OSPF in two ways. One way is what we explored earlier. Now another way can be router OSPF 100 exit. Then I will select both of my interfaces using the range command FA0021. Okay. In case, let's say your interfaces are not in continuation, like Syed mentioned. There was FA00, FA01, and FA1/0. Now that's not in continuation, right? So what to do in that situation? Put a comma and call FA1/0 like this. Clear? So the interface which is not in continuation, you can still make it a part of range by adding it with a comma. In our case, we just have 0, 0, and 1. So I will just select both of those interfaces and I'll say IP OSPF 100 area 0. That means I want these two interfaces to participate in area 0. Simple. I'll go to the next router. I will run the OSPF process, router OSPF 100, exit. I will select my interface range FA0021, IP OSPF 100, area 0, exit. Once FA00 and FA01 both are participating in area 0, OSPF 100, they will start exchanging hello messages and will become neighbor. Let's see if that happens. We'll have to wait for OSPF neighborship to come up. It's not that fast as compared to EIGRP. There we can see a log is generated that we have identified a neighbor 210.1.1, which is this router. Now you see this 210.1.1 is the identification number of this router, right? We call it router ID. So the router ID command that you guys got confused about was for basically adding or identifying these routers with, we can say, a special IP or a special ID that can help them to get recognized in the database. We'll be speaking more about it later on in the discussion. As of now, just understand that it is used for identifying the routers. Okay. Now, moving ahead, I will configure my final router, router 3. Router OSPF 100, exit, select my interface range FA0021 and say IP OSPF 100 area 0, exit. We can see the OSPF neighborship is up again. So it is just another method of configuring OSPF. And after configuring OSPF, I can expect a communication. So if I try to ping 210.2.2, I should receive my replies. For the first two packets, we didn't got a reply, then timed out, and then I got the reply. See, we are getting the replies. That's how we can configure OSPF using the interface commands. Now, is it all clear how this interface method works? Great question, Venkateshan. Very correct. If you enable it on loopback interface, it will send hello packets on that interface also. Sayyed, I have mentioned router ID is something we'll speak about later on. It is right now, just understand it is used for identifying the router. Pooja, INTR was the short form for interface range. I hope that makes sense. 100 is not router ID. That is your OSPF process ID. We have not configured any router ID here, and it automatically takes up router ID. So when you see your neighbor 210.1.1, that's your router ID for router 1. Similarly, 210.2.1, that's the automatically taken router ID for router 3. This number 100 is process ID, which defines, or we can say, which identifies the OSPF process. How to check router ID? You can find the router ID in neighbor table. For example, if I go and check my router 1's neighbor table, for which the command is show IP OSPF neighbor. So you can see this is the router ID for router 2, the middle router. Clear? Similarly, if I go and check my neighbor table on router 2, show IP OSPF neighbor, I can see my router IDs for the connected neighbors. Venkateshan, this is a good question. Keep it with you as of now. Later on, when we will speak about, let's say, multi-area topology, when everyone is introduced with loopback interfaces, I will definitely answer your question. We use passive interfaces for such a type of scenario. Okay, so I'll show you guys what exactly that means. Okay, let me address this question right away. So we have a question. What will happen if loopback interfaces are added in OSPF? Will we send hello messages there? Now, the very first question is, what is a loopback interface? A loopback interface is a virtual interface that we use for testing communications. For example, let's say you want to test communication, or you want to make sure that a network which I might connect in future, which is, let's say, 210.3.0/24, should also be able to communicate with these devices. So how can I test that? I don't need to connect another switch for it. I can create a loopback interface for it. I'll go to my router. I'll say interface loopback, and it can be any number between this range. Okay. I will create loopback 0 and I'll configure IP address on it from this network 210.3.0, 210.3.1, let's say 255.255.255.0. No shutdown, exit. Now, if I show you show IP interface brief details, along with your physical interfaces, you also have a loopback interface, which is a virtual interface. Are we clear so far? Now I will add loopback 0 also into OSPF. So I will say interface loopback 0, IP OSPF 100, area 0, exit. Clear? After that, I can try to check my connectivity with the loopback interface. That's a virtual interface, right? It do not exist in reality. But I can check my connectivity from, let's say, PC7. I'll go to PC7. I'll try to ping 210.3.1. As I get my replies, this confirms that if in future I add an interface on the subnet 210.3.0 and I simply add it like this into the OSPF configs, I will be able to make them communicate with all of my connected devices. That's how the loopback interfaces are used for testing or checking communications between devices. Questions or doubts so far? Yes, FA00, FA01, both are part of area 0. Sham, if routing is not configured, there will be packet loss. But because loopback 0 also is now participating in OSPF, we can send traffic to it. Okay. And obviously, the destination MAC is something that we will still require. But yeah, if ARP would take a lot of time, then there can be a packet loss. Okay, so we have another great question, how ARP would work. If I show you show interface loopback 0, these are the details about loopback 0 interface. And here we can see the interface is configured with the IP 210.3.1. So when an ARP request would be generated by any device for the 210.3.1, we will reply back with the destination MAC of the router. Okay. I just have confirmed you guys that loopback interfaces are used for testing communications when you don't want to add a new interface for just making sure that if communication is going to happen or not, right? So the only reason or essence of using a loopback interface is to test reachability between devices. It's a virtual interface. We are not utilizing an actual interface of router for testing. We are just using a virtual interface on the router which we have created for checking if the reachability is there or not. Any other questions, guys? Michael, I have already shared the lab guide. That's for configuring OSPF in a single area. Now it's up to you how you take that understanding and use it in different scenarios and experiment your learnings there, right? Any other questions regarding what we have tried and learned today? If you have to select multiple interfaces, we can go like this, FA0/0 to 1. But if let's say something is from a different range or a different uh, interface is there, which is not a part of your range, then you can add it by using a comma like this. Guys, we'll have to wait. We have to be patient, right? We will understand multi-area topology also. I have mentioned it earlier that we will speak about it in the session, right? So don't worry, I will speak about it in the session tomorrow. I don't want you guys to get overwhelmed with a lot of information in a single day. That's why we are keeping it slow and simple. I want you to understand and use this information in your productions, right? So we'll keep it slow to understand the protocol and use it well, right? All right, then I think we are good for the day. We will continue more discussions and more understanding on OSPF tomorrow, where we will speak also about multi-area topology. Thank you so much. Take care. Bye bye. I'll see you all tomorrow at the same time.